In this lesson, we're going to learn about square roots. We've just been learning about exponents, and there's one type of exponent that's extremely important for square roots. That's when you have some number to the power of 2, and it's always the power of 2. And I'll explain why they call the power of 2 a square. Um, think of it this way, if I use some manipulatives. If I had a square and it was 1 unit by 1 unit, then that represents 1 block. If I made that square 2 units by 2 units, then that's not only 2 blocks wide, it's also 2 blocks tall, which makes it actually 4 blocks in total. So your 1 block here actually becomes 4 blocks here. Now we can continue to do this. If it's 3 blocks in length, and we were to still make it into a square, so something with the same length and the same width, then we would see that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 9 blocks total. So as you can see, this number is getting big quite quickly as this number just goes up in a regular pattern. And finally, I'll show one more. If we had it 4 blocks by 4 blocks, then it would be, there we go. So we still have it made into a square of 4 blocks by 4 blocks. But the number of blocks that's now in here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 blocks now in this square. So that is why they call anything to the power of 2 a square, because 1 times itself, or 1 squared, gives you 1. 2 times itself, or 2 squared, gives you 2. 3, or it gives you 4, am I mistaken? 3 times 3, or 3 squared, is 9. So as you can see, as it goes up by 1 block each way, it goes up much more than one length in its actual area, or the total number of blocks you need to make it. And finally, 4 times 4, which is the same as saying 4 squared, is equal to 16, right here. So, how is this information useful for square roots? Well, square roots is actually the exact opposite to that. It's asking if you had to make a square out of 16 blocks, then how big would the sides be of that square? Remember, a square always has the same length and the same width. So basically, if you had 16 blocks, you can only make a square that's 4 sides, or that's 4 units on each side. Similarly, if you had 9 blocks, you could only make a square that had 3 units on each side, and so forth and so forth. If you had 4 blocks, you could make a 2-sided unit, or 2 unit sides of your square. And finally, if you had just 1 square to work with, it would be 1 by 1, obviously, because you only have 1 to work with. So let's look at all of our squares. I'll write down the ones that we already had before. So 1 squared is 1, 2 squared is 2, or is 4, 3 squared is 9, 4 squared is 16, Now 5 squared, 5 times 5, is 25. And you could do this with the blocks if you want, but I can tell you what it is very quickly. 6 squared is 36. 7 squared is 49. 8 squared is, make sure you're very clear with your squares that they're not part of the number. 8 squared is 64, and 9 squared is 81. Now, we can continue by going to 10 squared, and 10 times 10 is 100. Now you've got the first 10 digits here, and these ones you can calculate fairly easily, and hopefully at some point you just basically memorize it, because those numbers are very, very commonly used in a lot of things. So it's really good just to know those almost by heart. But after that, you can actually find out a whole bunch more numbers just with one simple little trick. And that is, if you look at what we've got here, we've got 1 squared is 1, and 10 squared is 100. So the only difference is when you have a 0 on the end, which is a tens digit, something in the because you've got something in the tens column and then 0 in the ones column, it becomes 2 digits long in its square. So, or when you square it. So if you watch, if you decide to square 20, then you'd be left with 4, and your 1 0 again turns into 2 zeros. 30 squared is going to be equal to 900. 40 squared is going to equal, well, 16 and then 2 zeros, so 1,600, or you can even say 1,600. 50 squared is 25 with 2 zeros. 60 squared is 36 with 2 zeros, so 3,600. 70 squared is 49 with 2 zeros. 80 squared is 64 and 2 zeros. 90 squared is 81 plus 2 zeros. And then finally, 100 squared is 10 squared, so that's 100 plus 2 zeros. So it's actually 10,000. So if you just remember this little pattern, you can really get a number of squares all the way up to the square of 100. Or if you're looking at it in the opposite direction, because as I was saying, the square root of 1 is going to be 1. The square root of 4 was 2. Square root of 9 being 3, and square root of 16 being 4. The same thing applies here. So you can find very easily the square root of 2,500, which is quite a big number. But you can very quickly find out that it's 50. So how is this information useful for us for finding other square roots? Well, a lot of the square roots you come across normally are really going to be in these numbers here and up to 10. However, if you get above that, so for example, let's say we wanted to find the square root of 729. So we wanted to find the square root of 729. So what that means is there's some number, we don't know what it is, some number, and when you square it, or you times it by itself, it's going to give you 729. That's the same thing. So we're looking for what this number could be. So the first way we can sort of narrow down our search is to look around. And 729, well, it's bigger than 100, it's bigger than 400, but it's actually smaller than 900. So we know that the number we're looking for has to be somewhere between 20 and 30 because our answer is somewhere between 400 and 900. And we can guess sort of if it's closer to the 900, then it'll be a bigger number, or a number closer to 30, I should say. And if it's closer to the 400, it'll be a number closer to 20. And remember how the numbers do go up in a faster fashion, though. Like they start going up just by a little bit. Like this goes up by 3, and then this goes up by 5. But then they start getting bigger quite a bit. You can see the jump here from 64 to 81. That's a fair-sized jump. So it isn't an exact, in a really easy way to guess, but you can sort of figure it out a little bit. So I'm going to start by saying that our number 729 is somewhere in between 400. So let's go halfway between 20 and 30. So let's use the number 25. And let's see what happens when we square 25. So if you can use your calculator, or you can do the math longhand. I'll do it longhand. So if I had 25 and I multiplied that by 25, then I would very quickly have 5 times 5 is 25. Carry the 2. 2 times 5 is 10, so 12. And then 5 times 2. Oh, first of all, sorry, put the 0. 5 times 2 is 10. And 2 times 2 is 4, plus the 1 is 5. Add those up, and we have 625. So we know that 25 squared is the same as writing 625. Well, we look at this number, 625 is still smaller than 729. So we know that the number that we're looking for is higher than 25. So we could go 26, 27. I'm going to say it's still a little ways higher, so I'm going to guess 27 because that's maybe a little bit closer. So if we go 27 and square that, we'll have 27 times 27. So we've got 7 times 7 is 49. Carry the 4. 7 times 2 is 14, plus the 4 is 18. And over on this side, we've got, I'll erase the 4 there. We've got 2 times 7 is 14, so the 4, and then the 1 goes up here. 2 times 2 is 4, plus the 1 is 5. So we have 9 plus 12, carry the 1 up here, is 1 plus 1 plus 5, 729. Well, that number is the same as that number. So we know that the number that we're looking for here, so the square root that we're looking for, so we had some number squared is 729, and we know that 27 squared is 729. So we know the square root of 729 must be 27. So hopefully this has been helpful. I should have mentioned this is the square root symbol. So this symbol, all it means is it's the root, or the base number of, or basically it's a number that has two identical numbers that multiplied by each other. So a number that is squared will give you this number, and so all that symbol means there is square root. Anyways, I hope you find this useful.